All right, we're going to do a video here to show you how to manipulate the diesel engine test data that we collected in lab. I'm going to leave all the mistakes in here so I could try to get the video made a little more quickly. All right, so for those maybe listening who aren't part of the class, this is what we've done, is we used this test engine right here, and it's got a motor slash generator and connected to a load bank, and we connected a computer to this interface that had a pressure transducer, and we were able to collect with the proprietary software from Gunt. We were able to collect pressure, angle, and volume data. And so we're able to create PV diagrams and pressure crank angle diagrams. One thing of note is that we had the averaging put on there, and we would capture a curve. I think it's one of these buttons here. We would capture the curve, and you would freeze the curve that we would do, and then we would save it to a particular file that we would then be able to export into Excel. So that's what we're going to do. And here's the engine itself, and here are the parameters here. It's got an 80 millimeter bore, 69 millimeter stroke. That's I believe this engine right here for 347 cubic centimeter displacement. Okay, so let's end this show. We'll discard the information, but we're going to continue recording. All right, in Excel, we're going to I want to have this thing so it stays here all the time. How do I do that? Well, I guess I'll leave it for right now. We're going to import this data. So I have a sample data going on here in my documents. And where are my marine engineering videos? Okay, I need to have it as all files. Change this. And there's the sample data that I collected, and I'm going to go open. Now, it's going to need to use the delimitation. That's a hard word. And so I want to take a little peek at the data here. I need to pull this down, and it looks like it's going to recognize how to break up this data into, so it can make it into cells. So I go to next and finish. And what we have left here is some preliminary information that the program has saved for us. It saved us an indicated mean pressure, mean effective pressure, MEP. So it's IMEP, and they also indicated power, recorded the RPM. I think perhaps I wrote this stuff in here. I don't know. There's a place for user comments. I guess my user comment was 2,800 RPM. These are things you're going to need to record, or we recorded, I guess, at this point when we did the test run. Okay, so starting out here, I'm just going to show you how to make the graphs, and some of these are going to be my preferences. I start by grabbing some of these, and now I'm going to scroll to the bottom. 1 second here. I need to change my screen orientation so I can use this a little more effectively. Here we go. All right. I'm not sure what that looked like for you. But anyway, I hold down Shift after having selected some and click down there so I have it all. I'm going to go Insert, and I'm going to Scatter Graph. And for this, I'm going to use lines right there. Okay. Now, I don't want it here at the bottom, so I'm going to go ahead and go Control X, scroll back up to the top, click somewhere, and hit Control V. So now I've moved it up near the top of the screen. I'm going to stretch it out. I don't like these horizontal grid lines that are the default in Excel, so I'm going to get rid of them. I'm also going to get rid of the legend here. Now you'll notice that because just the location of where the pressure was relative to the volume here, and this is normalized volume, by the way, so it goes from 0 to 1 here in the y-axis. I want to change those because we want a PV diagram, not a VP diagram. So here you go. We're going to actually click on this. If, by the way, if you were to click on this portion right here on the outside, you won't be able to move these. So we have to actually click in here and click on that data. I'm going to grab this guy and I'm just going to move him over to the side for the time being. You'll see that nothing shows up, but now I'm going to move the blue one over. So now that's going to be volume, and now I move this purple one back over. Now we've switched what's being graphed versus what's being graphed. While we're up here, I'll show you, I'll start using this instead of right-clicking so much. We can go to Format. You know, we have the thing active. That's the curves active. We can go up here and we hit this Format button underneath Format, hit the Format selection. And I'm going to change the line style. Defaults to this really thick line. We want to get rid of that. Make it down to, I think something right around 1 is probably enough. I'm also going to get rid of smooth lines because we'd rather see some of the imperfections and instead of having it try to fix it for us. So we could see this pretty well already. By the way, while this is still open, this format thing, we can click other things. Like we could click on the scale right here. We can change these. I'm going to highlight something here. I'm going to make this the minimum fixed, make the maximum. I'm going to make it 10 because we can't really see something with it 80. I'm going to point this out, move this over to the side. But you'll see that there's this area underneath here. And for one thing, this is a naturally aspirated engine, so it's actually going into vacuum on the intake stroke, right? So, so there's an area in here. Just note that that actually represents a pump work, where the engine is during its intake stroke, right, from moving from here to there, is actually, let's see, it's going to move from bottom dead. It's going to be moved from top dead center to bottom dead center. Yeah. So it's going to. Let me see if am I right on that. So this is going to be bottom dead center here. Yeah. Okay. So it's moving from top dead center to bottom dead center. It's actually sucking up air as it's doing that, and that is a resistance that's causing actual work. So it's drawing in this vacuum. So that's a negative work actually for us. So it detracts from our overall output. But I figured it's a good place to probably mention this. So I'm going to bring this up, and I'm going to go ahead to auto. Let's see. No, that's that we go to fix. Yeah, go auto. We can go auto either one of these. On this scale, we only care about 0 to 1. So let's fix that. There's also other things. If you were to get rid of this, and you'll see the box around it, I want to, just for display purposes, I want to get rid of that box. So I click on this outside and do that format, and you'll notice the border color, we can get no line, right? So it's nitpicky, but it makes it, I think it makes it look better. So let's see. Other aspects of this that we might want to change. I think that's probably okay for now. Oh, by the way, yes, I wanted you to include the titles. So we go to axis titles, and we go below, and also, layout. We go axis titles, vertical, rotated, and I'll call this pressure, and the units are bars, and I'm going to go title down here. I'll go, I guess normalized volume. I guess I don't need to give units to that because this is 0 to 1. Okay, and let's see, I guess I'll go ahead and finish up with the graphing part of this. I'm going to Control C, and I'm going to put this right next to it, and we're going to use the same graph so we don't have to change things. And we'll move this, we'll change what we're going to do because we want to have the pressure versus crank angle, which we already have over here on the left. So clicking onto the data here itself, we can move what is the X values, which is the normalized volume. We'll put it over to there. Now, because we changed this scale before, we need to go back and change it to auto. All right, now you'll notice this is not the diagram that we're used to. That's because they decided to start at near top dead center. We'd like it over to the side. So what I do here, okay, I stick in another row. So I select that, go insert, and maybe I stick in equals this plus 360. Okay, and I'll scroll down to till I get to let's see, till I get to 360. Excuse me. And then I'll go over here and I'll go that minus 360. I think that's going to be okay. Let's see what happens with this. All the way down to there. Okay. And back to the top. Now I can grab a hold of this and change that to there. So now you see what we have here is what looks like our pressure versus crank angle. So let's change the name to this and go crank angle brackets degrees. Okay, let's change this x-axis here. So we go to the format, and where are we at? Format selection. I'll go from 0. We want 720 is our extent, and we'd like to have something that's nice divisible there. 90 works pretty well, and I'll go ahead and say select that. Okay, so we have 90. Now here's where I want to do some grid lines, because they're going to help us figure out where we are. So I'm going to go primary, and I'm going to go major right here. Now because I set the grid lines to because I set the minor scale here, the minor ticks to 90, you can see that's where my grid lines are going to appear. Now I prefer to not have to see them that large, so I'm going to click on the grid lines and format them. And on my line style, I'm going to change it down to dashed, and I'm actually going to change the line color to something that's relatively non-obtrusive there. So it's just going to barely show up, so I can kind of like figure out where I am when I want to do my markings. Now I guess I'm going to go ahead and leave my scale here from let's double check what it is. Yeah, I'm going to purposefully force it to be 80. And now for presentation, what I want you to do is copy this first PV diagram, and in Word, let's see, I'll zoom out so you can see this. I'll Control V and paste it in there. All right, now I'm going to go ahead and hit enter a couple times and do insert no, here go page layout and go break, and I'll go next page as a break, and I got to do this, so I'll hit enter a couple times, go back to the top and go orientation, change it to landscape. All right, so let's see, so you see see both pages here. We have portrait over here and landscape over there. I feel like portrait is better for this particular diagram here. And let's see, moving the thing up, I think I have get a couple deletes, so I can go back up to this guy right here, and in here I can go ahead and grab this crank angle, Control C there, and then paste him into this landscape orientation, which I think is going to be superior for presenting the pressure versus angle diagram. So let me zoom in here a little bit. So I guess this is going to be good. What I asked you to do was to print this out and then to label various parameters along here. Some of them that might be tricky are the points 3A and 3B of the that correspond to the ideal or the dual cycle. Just do your best where you're marking those. I kind of think that combustion begins right around here, but it's actually probably going to combine like right around here. So we can think of the compression that moves up, like we could say that 2 ends up like somewhere like right around here, right? And then that constant volume heat addition is going to be like end like right here. So maybe 3A is like right here, and combustion maybe ends like maybe over here for 3B. But it's going to be something similar there, where this is approximately maybe where 2 is, 3A is something like right around here, and 3B is something along there. I'm just trying to give you a better explanation than is in the lab write-up, lab instructions. Other things that you could do to this, just mention to you that sometimes it's better to like match, maybe make your fonts a little bigger for the labels, but we would prefer that the axes maybe be a little smaller, so you could just click on those in Word and make them, we don't want to go too smaller than like maybe a 10 font, but we might want to match whatever we have in the document as our font for our axis label. And I went ahead and I kept went down to 10. I would prefer most of the time to keep 0, but I went ahead kept as -10 just because I wanted to highlight that this thing is below. It's drawing a vacuum, and the same thing true for over here. They could see where things are taking place. But anyway, okay, so that's this is like a document. You could print this out and then hand label those other points on there. Now, this is the other part of this, what I wanted you to do to get some experience in doing a little bit of analysis. I'm going to have to wing this a little bit. Let's see. Okay, I'll go ahead and right here, we got normalized volume. Maybe I want to get this out of the way by wrapping the text there. Okay, I'll make the thing a little bigger. Looks kind of weird now. All right, there you go. This I'm going to go and write area. That sounds good enough. And what I'm going to do is really technically a numerical integration. We're going to use the trapezoid rule. So I have equals. What I'm going to do is I'm going to take and I'm going to go one line down. Right, I'm starting from in this one it's going to be E26 in that cell, and I'm going to go one line down from the top, and I'm going to take the average of this pressure and the previous pressure. So I went parentheses, that one plus that one, right? And I'm going to divide it by 2, so that's the average of that. And now I'm going to multiply it, and this seems like you should just do an increment, but this is actually going to help you out in a moment. I'm going to take that normalized volume, and I'm going to say this cell minus that cell. Okay, so what we're really going to get is an increment right here. So this is like the height, the average height we're going to take maybe of like right here, and we're going to make it a little rectangle that has a very small width. That's actually only going to be, for the crank angle, it's going to be very small. So we're going to get a number here. Now, here's a technique that maybe you're not familiar with, is when you're highlighting over a cell, you can hover right over this bottom right-hand corner and just double-click that, and it goes all the way down to all of the cells that are happening. Now, you can see that some of these are negative. That's because the volume changes depending on as you're going down. Like this crank angle, as we're moving along here, is really sort of like a path, right? We're just kind of following. We're starting at one place right here. If you consider that to be 0, we're moving and we're moving and going in the positive direction as we're going down here. So this is really, we're beginning at the power stroke with the way this is arranged, or a little bit just before the combustion is part of the power stroke. So we're coming down to the power stroke, and so these are positive. But then we're just going to start moving and go through the exhaust. And so when we get to approximately, let's see, did I do it yet? So when we get to, I'm moving through these things and not saying, oh yeah, we got to move to 360. There you go. I was looking at the things over to the side instead of the actual. All right, so when we get to approximately 360, you can see that we're going to, oh, well, we also, because we have a negative pressure, no, I said that wrong, excuse me. When we get to 180, there you go, yes, all right. And I'm going to leave that in there so you can see all my mistakes. When we get to 180, you can see that we're going to start going in the other direction, so it's going to be negative. What that's going to do is going to give us like a negative area. And so the sum total, when we add all of these little tiny areas up, what we're going to get is the area inside this curve. We're also, believe it or not, going to get the area inside here, but that's going to also be a negative area. It's negative, negative, negative. I know, a lot of negatives. And that's going to subtract. So if we sum up everything that we just did right here, and I'm going to bring it up here to the top, and let's see, where will I stick it? Maybe I'll put it right there. I'm going to stick, and I'm going to go auto sum. Right now, it thinks that I want to do there, but I really want to go to here. I'm going to go to this and say that that's everything I want. Okay. Now, this is going to be perhaps a little confusing here. But what I would do to be able to find the mean effective pressure, right, is I would take this area right here and divide it by the total volume, okay? But it's already been done for us, dividing by the total volume, because these are normalized volume, okay? Another way that I could have shown it to you is I could take this volume right here, and I could multiply each of these normalized volumes by the total volume. So now we would actually have, and I could regraph it if I wanted to, pressure versus volume, real volume, not just normalized volume. But then I would take the area of that, and then at the end I would divide by the volume. So that's like the difference here between, like, I'm just skipping a step. Maybe that's the way to say it. So what I have here is the average volume that's taking place. If you recall from mean effective pressure, mean meaning average. That's really what we're talking about. And so this is going to be measured in bar right here. And maybe I should have moved it up to the next line, because this is what the computer is saying. It's doing its own numerical integration of this system right here, and this is our numerical integration. You could see that they're pretty close to each other. Zooming into the data, we can see that there's quite a bit of a stagger going on here. This is not the perfect. Let's see, I'll even make it a little thinner here, so you can see the amount of scatter that's really going on. And but the truth is, this is actually still pretty impressive within the last decades, a couple decades, that we can get a sensor that's that quick of a response, because this is happening in milliseconds right here. So it's really a fast data collection rate. Okay, so anyway, this is the mean effective pressure. And what we could do is we could, if we recorded what the RPM was going to be, we could use that equation PLAN, some plan, which would be pressure is the P, or mean effective pressure, times L, which I believe is the stroke, area, the bore area, times our N, which is RPM. Right, but we have to turn that into radians per second, I believe, or maybe no, just cycles per second. So we just have to divide by 60. But anyway, and having divide by 1,000 in there, I believe you might have to do some other manipulation, but you'll be able to get into kilowatts. And what that will be, all right, is going to be the indicated power. and we could compare to what we have here. Hopefully they're going to come out to be pretty close, or probably be off by each other by the same amount that we're off here. I made the comparison. I think for this one was like about 3% difference, which isn't too bad. And I got about the same 3.3 or something like that percent difference between indicated power that I got from my numerical integration and from what they got. And the purpose of doing this is to show where it came from. It's not magic. It's pretty straightforward and simple. But there's going to be, but a trapezoidal rule isn't a perfect numerical integration. There's lots of other strategies to try to get better information. And then lastly, what we want to do is compare this indicated power to what we measure, what we could say is produced power. Now, our unit here has a torsionometer, right? We have this beam that the thing is balanced on, and we have a force block, and it reads out what the torque is. So the torque or load that's being recorded here and the RPM, we can use those together to find power, and that's the delivered power. That should be less than our indicated power. Okay, so that's what we have for this lab. I think you'll be able to get a lot out of it after doing it. I know I went relatively quickly going through the graphs and so forth, but I think you'll be able to work your way through it and pause it, go back, and without too much more effort, you'll be able to produce the same graphs I did and then just annotate them as directed. Well, that's all I have. And